Hi all, myself Ratnakaram Raju from the Competitive.in, the only one platform at your service at any time to enhance your skills. In the last videos, we described about many topics. In this video, we are going to discuss about electric motor. Then go to next slide. Magnetic force on a current carrying conductor. The main definition for the electric motor is electric is the electrical energy is converted into mechanical energy. It is the basic principle which is in the electric motor. For example, why as we know, many of us are using the electric motor in houses for to transfer the water which are in the pump to tank. So here the electrical energy is converted into mechanical energy. So the water from the sump or bottom to be transferred to the higher altitudes. Magnitude force on a current carrying conductor. The magnetic force, here F is denoted by magnetic force, and the conductor expenses is equal to the product of its length within the field. The current the current is denoted by I, and the length is denoted by capital L. The external magnetic field, and the magnetic field in short, is given by F equal to Bill sine theta, where B is the force and I is the current, L is the length, Sine theta. Theta is the angle. Then go to another slide. The force on a current carrying conductor in a magnetic field. When a current carrying conductor is placed in a magnetic field, there is an interaction between the magnetic field produced by the current and the permanent field, which leads to a force being experienced by the conductor. For example, here I shown two diagrams. In the first diagram, all the rays are falling, all the lines, those are the magnitude, uniform magnitude lines are falling from up to down. Those are denoted by permanent field, and the green arrows are given by field due to current. In the second diagram, blue is denoted by resulting field, and the pink is on the force on the conductor, where it is the P. The magnitude of the force on the conductor depends on the magnitude of the current which it carries. Yeah, it's a very good one. For example, let's say take a conductor and it be connected or turned by the copper wire. The current direction is shown by the thumb, and the current and the flux is given by the our folded hands. The force is a maximum where current flows perpendicular to the field and parallel to the field. As in the first diagram, the current is in the downward direction, and the magnetic field in the towards the right direction. F equal to force equal to F max. For example, where we have current and magnetic field in the same direction, then there is force 0. So what we need to know, what we need to understand here means, for example, to get the maximum force, we need to current and magnetic field place in opposite direction. Whenever we place in the same direction, then there will be no force. Fleming's left hand rule, and it is called as the father, mother, child and rule. Here the thumb is called as the father, and the arrow is called as the mother, and the ring finger is called as the middle finger is called as the children or current. The middle finger father, which is called as the thrust B, and the mother finger is called as the forefinger of field, magnetic field, and the second finger and the middle finger is called as a current. So Bill, B-I-L or F. Then go to another slide. The directional relationship of I in the conductor, the external magnetic field and the force the conductor experience. Let's take a magnitude which is of north and south pole, which is placed in between the same. For example, if you place two bar magnets of north and south pole in the same direction, they will repel or they will diverge into two directions. As we know, opposite poles will attract, same poles will distract. For example, if you place a north and south pole and south and north pole nearer, they will attract, and there will be uniform magnetic lines will be generated there. As I shown here, for example, if a conductor is placed between a magnetic, it seems to be a conductor, and the magnetic lines are formed here. It is shown by green, and F is the force, I is the current, and B is the magnetic flux. Then go to another slide. Motion of a current carrying loop in a magnetic field. Here N is the north pole and S is the south pole of the bar magnet. Two bar magnets, and here a rectangular current carrying conductor is taken. In the L, the force is acting downwards, and in the R, the force is acting downwards. Then it forms to be rotated on the same direction. The rotation is given by in the green, and the brushes and commutator rotates the coil. Here splitting also called as a commutator, which are made up of a small rings to reverse the current. Okay, then go to another slide. Vertical position of the loop. As I said earlier, if the force in the left downwards and the force in the right upward, then it will be rotated. For example, the horizontal position one time and the vertical position one time. The current may reverse up to sometimes. Then go to another slide. Electric motor, the basic electric motor. An electromagnet is the basis of an electric motor. An electric motor is all about magnets and is all about create motion. Opposites attract and likes repel inside an electric motor. These attracting and repelling forces create rotational motion. A motor is consist of two magnets. Then go to another slide. Parts of the motor. The basic parts of the motor are armature or rotor, commutator, brushes, axle, field magnet, DC power supply of a some sort. Sorry, armature or rotor, commutator are the split rings. Then go to another slide. Motor illustration. The up diagram which is shown here is the basic motor, where we have frame, armature, bearing, shaft, starter, commutator, brush assembly, and bracket. Here the below one is given from north and south pole, where the split ring is placed between axle, armature, commutator, brushes. Brushes which are made up of carbon are shown here. Then go down the slide. Armature. What is meant by armature here means the armature is an electromagnet made by coiling thin wire around two or more poles of a metal roll or core. The armature has an axle and the commutator is attached to the axle. When you run electricity into this electromagnet, it creates maxis in the stator, so armature spins through 180 degrees. As I shown here in the right side of the diagram, we may find some of the magnetic field lines and some of the armature movements. To keep it spinning, we have to change the poles of the electromagnet. For example, if one of the bar magnet has a north pole, then we need to change the pole of the another magnet to be south pole. Then go to another slide. Commutator and brushes. Commutator is simply a pair of plates attached to the axle. These plates provide the two connections for the coil of the electromagnet. Commutator and brushes work together to let current flow to the magnet direction that the electrons are flowing at the just right moment. This is about commutator and brushes. Next, go to another slide. The contact of the commutator are attached to the axle of the electromagnet, so they when spin the magnet. The brushes are two just pieces of a spindly metal or carbon, as I said earlier, that make contact with the contacts of the commutator, as is shown here in the diagram. Spinning armature. North and south pole is shown here, and the armature is shown here, and the blue lines is to battery, which is connected conducting wires. Then go to another slide. Example of motor is given here. Uh, the central magnet is shown. A copper wire is spinned or turned to a rotor, which makes it acts as a the copper wire, when it is passed through a current, then it acts as a magnet. So it is the one which mainly acts in the electric motor. And as in the last videos, we have some questions. In this video also we have some questions. But before that, I need to say some of the types of electric motors are there. They are synchronous, single phase, three phase, AC motors, DC motors. AC motors means alternate current motors, in which alternating current taken as input. DC motors. DC motors are also same type, in which DC motors are taken DC current as their input. And we have many types like AC brushless motors, DC brushed motors, DC brushless linear servo stepper motors are there. The basic main principle in the electric motor is electrical energy is converted into mechanical energy through the electromagnetic induction. It is a direct bit which is asked in many competitive exams. So I need to repeat it one more time. The basic principle in the electric motor is electrical energy is converted into mechanical energy through the electromagnetic induction. Here are some of the questions regarding the topic. Let us take a north and south pole, and in between we placed here a split rings and a rectangular conductor here, and a current carrying coil in a magnetic field experiences a turning effect. As we know, as I said, yeah, it says how can be the turning effect be increased. So let it be the question, and if any one of you know the answer, please be in the chat box. Then go to another question. What are the directions of the force in the left and right light loop? This also be the question, and it let it be answered in next video. If anyone know the answer, please be in the chat. Please be in the chat box. And this is the reference question which is taken from the mains, as my cousin suggested. Take it, and a student set up a apparatus shown in order to make a relay. Here a conductor which is turned with a core of conductor. Okay, question is asked, which metal should be used to make the core? Mainly, what is the metal which is used to make the core? Let it be the question, and if anyone know the answer, please place it in the chat box. I will see, and I will assure that, and I will briefly describe and set the answer in the next video. You are Ratnakaram Raju from the Competitive.in. Thank you.